A solid disk of mass m and radius r is spinning with angular speed omega naught about an axis perpendicular to its center. The rotational inertia of this disk is I equals to 1/2 mr squared. A brake is pressed against the edge of the spinning disk with a force of magnitude F directed towards the center of the disk. The friction of the disk and the brake slows the rotation of the disk, which comes to a stop in 2 full rotations. What is the coefficient of kinetic friction between the brake and the spinning disk? First, note that it says 2 full rotations, hence it basically rotates. 1 rotation is going to be 2 pi, so 2 rotations is going to be 4 pi. Let's look at what we have. There is definitely torque caused by the brake on the disk. Remember that torque equals I alpha, which is also equal to RF sine theta. Let's set these equal to each other. We know that the radius is r. We know that the force caused by the brake is going to be the normal force. And hence, remember that the equation for frictional force is going to be this. Hence, we're going to have this. Remember that because the brake is acting orthogonally to the disk, sine of theta is going to cancel out to 1. We have this equation. Now let's solve for alpha. Recall that angular motion, or like angular kinematics, works the same as linear kinematics. So we will be using this equation. And because of this, we can substitute what values we know. Initially, the solid disk is spinning with angular speed, and then it comes to a stop in 2 full rotations. So we can substitute those known values in, where we have for pi comes from our theta on top because it comes to a stop in 2 full rotations. Omega is 0 because it stops. Omega, yeah, okay. I don't think I have to explain this. Substitute in value for alpha that we found. And basically solve for mu in terms of literally everything else. And, okay, I don't know where this negative sign came from, but, it really doesn't matter, because if you look at what we have, disregarding the funny little negative sign that there is for some reason, you will notice that it is very, very similar. And let me just rearrange it for you to answer A.